This video is going to go through applications of linear systems. So this is when they give you a word problem, how do you set up a system and then solve it? The tricky part with these is just figuring out what the equation is. And then once you have the equation, you're just going to use one of our 4 methods of solving. So graphing, substitution, elimination, or Cramer's rule to solve the system. This video is just going to go through how you set them up. It's not going to go through that solving piece. So first example is when we have amounts and money that are mixed. So the first step in all of these is going to be to annotate. Annotate is a fancy word of saying mark it up. What is the important information? So let's read through this. The newly renovated Morris Theater will seat 1,500 people. Reserved seats will cost $8 each, and all other seats will cost $5 each. How many of each type of ticket must be sold for the opening performance if the new owners want to generate a total of $10,500 in sales? So, important stuff here. Newly renovated Morris Theater will seat 1,500. Reserved seats will cost $8. All other seats will cost $5. How many of each ticket must be sold for the opening performance if the new owners want to generate $10,500 in sales? So once we know what our important information is, we have to figure out what our 2 variables are. So it's asking about reserved seats and all other seats. So we're going to say reserved seats is X and other is Y. Now I'm going to organize my information in a table, and then this will help me to write my equations. So I'm going to have my reserved, my other, and then the other thing that it gave us is this total piece. So this is total. So I have the number of seats. So I don't know how many reserved seats there are. I don't know how many other seats there are, but I know that there are 1,500 seats total. Now money. So I know that reserved seats cost $8. I know all other seats cost $5. And I know that all together we want to generate $10,500. So I'm going to write expressions now to represent this. So this is basically 8 times x. So our expression is 8x. Y times 5 would give me 5y. And this is still just going to equal that 10,500. I'm not going to do anything with those 2 numbers. Once I've set up my table, then I'm going to write my equations, and I write it by going down this column. So my first equation would be x plus y equals 1,500, because some amount of reserved seats plus some amount of other seats equals 1,500 seats. Then I'm going to write down this column. So 8x plus 5y equals 10,500. So I know that 8 times the number of seats x, so $8 per seat plus $5 per seat is going to equal $10,500. Once we have these equations, then it's just solving a system of equations. This one would be great to use elimination or Cramer's rule for, because they're both in standard form. Graphing or substitution we'd have to do some manipulation with, so standard form would be better for this. And then your final step is going to be to check that your solution makes sense in the context of your problem. So can you have negatives or fractions of things here? We should not have any negatives. Because we can't have negative seats or negative money. We also shouldn't have fractions because fractions would be parts of seats, and we can't have that here. So that would be how we set up when we've got amounts and money mixed. Let's look now at just straight money. So this would be money with an initial amount. Annotate, so we're going to mark this thing up to start with. So DSC Printing Company writes paperback books for authors who wish to self-publish their works. They charge $15 per book plus a setup fee of $1,200. If an author uses this publishing company and sells each book for $25, how many books must be sold in order for the publisher to break even? This is the most key word here. This tells us equal. Break even means that how much you spend and how much you sell is equal. So identifying the variables, we are talking about books and money. So we're going to say that X is books, Y is money. Our table is going to look a little bit different here. So we're going to have our cost, because we're talking about that break even, it implies cost and income. Both of those are Y, because both of those are money. Then we're going to have number. So number of things would be, my number of things would be X. It's just per book. I don't know how much is per book. Money here. So the cost is $15 per book. The income is $25 per book. Now, there is also a setup fee. So there is a cost for us to start this of $1,200. The income does not have that same thing. So writing our equations for this one, we're going to write across our rows. So cost is Y, and then I'm going to do 15 times X, which is 15X, plus that setup fee of $1,200. Then my second one, I'm also writing across. So money equals $25 per book. There's no setup fee for that. So now is solving. So I could use graphing would be good here, because both of them are in y equals mx plus b form, or I could use substitution, because both of them have a variable that is isolated. Substitution. Finally, I'm going to check that the solution makes sense in the context of the problem. So can I have negatives or fractions of things? So no negatives. I can't have negative books. And I can't have fractions, no pieces of books. All right, next, solutions. So this is a very particular type of problem that you will see often, is when they're talking about percent solutions. So first step, again, I'm going to go ahead and annotate this. So how many milliliters of a 10% acid solution should be mixed with a 30% acid solution to produce 500 milliliters of a 15% solution? So let's identify our variables. We've got a 10% acid solution and a 30% acid solution. So my things here would be a 10%, a 30%, and then we want a 15%. I'm going to talk about volume, that's the milliliters thing. Concentration. And then, like my first table, I'm writing my expression. So volume would be, I don't know how much of an X, I don't know how much of a Y, but I know I want 500 milliliters at the end. My concentration, so I have to change these into decimals so that I can work with them. So to do that, I'm moving my decimal place twice. So move my decimal place twice. Move my decimal place twice. So those are my concentrations. My expressions is where I'm multiplying. So 0.10x, 0.30y. And this, I am actually going to multiply these together. So I've got 500 times 0.15. When I multiply those together, I get 75. So this is 500 times 0.15. Now I'm going to write my equations down my columns like I did on that first one. So I'm going to have x plus y equals 500. And then my expression 0.10x plus 0.30y equals 75. All right, so those are my two equations. So then I would use one of my four methods to solve. Elimination would be fine in this. They're both in standard form. But Cramer's rule would probably be better because I've got those decimals. And it's not terrible to have to multiply your first equation by a decimal. But if I don't have to figure that out, then I'd prefer to use Cramer's rule on this. All right, so since in the context of the problem, so still no negatives. You won't often have negatives in word problems, but no negatives. Yes, you could have fractions of things, because it would be fractions of a milliliter, which makes sense. You could have half a milliliter. So fractions would be fine in this case, no negatives. All right, let's look at a geometry problem. So geometry problems are going to be a little bit different because after we identify the variables, we're not setting up an equation or setting up a table. We're just drawing a picture of what they've described. So we're going to start with annotating it. So the fence surrounding a backyard playground has a length 3 times its width. The perimeter of this rectangular playground is 296 feet. Find the dimensions of the playground. So this word dimensions is the key. That tells me that I'm dealing with a length and a width. And we're going to call those L and W. So let's draw a picture for this. I'm going to have a playground. It is going to have a length and it is going to have a width. And I know that the length is 3 times the width. I also need the formula for perimeter. Perimeter is 2L plus 2 times the length plus 2 times the width. This is just a formula that I would have to look up if I didn't know what the formula for perimeter is, but I know it off the top of my head. So you're looking for that word there. What are they asking you to find? And then you need the formula. So my equations would be L equals 3W. And then for my perimeter, I know that I want the perimeter to be 296. So that's going to go in here for P. And then I have 2L plus 2W. So those are my 2 equations. Then I would go into solving using graphing, substitution, elimination, or Cramer's rule. The only one that I could use right off the bat here would be substitution, because I have a variable that's isolated here. I couldn't immediately go into anything else I would have to solve in order to graph to eliminate or use Cramer's rule. So substitution is nice and easy here. All right, and then check that it makes sense. I can't have any negatives as usual. I couldn't have a negative length, but I could have fractions. Because I could have half a foot or 3/4 of a foot. So fractions would be fine in this case. All right, final thing that we're going to look at is supply and demand. This is very straightforward. So supply and demand will ask for, it'll have the words supply and demand in the problem, which then tells you exactly how to set these up. And usually it's going to give you the equations, so you don't even have to write them, you just have to solve the system. So our strategy for solving these supply and demand ones is that we're going to set the equations equal to each other and then we solve them. So for our example here, the supply S and demand D in thousands for a certain product are given by the equations S, so this is the supply equation, F of P equals 3P minus 15, and D, so this is the demand, equals H of P equals 30 minus 2P, where P represents the price of the product in dollars. Find the value of P at the equilibrium point. So we are going to just go ahead and solve this one. So I'm just going to set it up. 3P minus 15 equals 30 minus 2P. So I'm using these two pieces. I'm setting those equal. Then I'm just going to go through and solve it like I would solve any kind of equation. So this is a one where you could do one of four things. You could subtract that 3P, you could add the 15, you could subtract the 30, or you could add the 2P. I'm going to go ahead and just add that 2P to both sides. So I get 5P minus 15 equals 30. Once I do that first thing, it locks in how I have to solve everything else. So I have to add 15 to both sides. I get 5P equals 45. Divide both sides by 5. And I get P equals 9. So what that means, there is an equilibrium point at $9. So that's our 5 different examples that should cover you for most situations involving systems of equations.